Hello students, once again welcome to Bholanath Academy. In this video students we are going to see the chemical properties of ether. Now you have ether. Now students we are going to see the chemical properties of ether. In your hand you have ethers. So students, how to test the ether? For that students we are going to use the chemical. So chemical properties of ethers. Okay students, you have ether. Now we are going to test the ether in laboratory test for ethers. Students, in lab how you are going to test the ether? This is ether. Okay, whether this is it. Ethers are neutral compound. Students, mind well, ether is very neutral other than hydrocarbons. Ethers are neutral compound in aqueous medium. Okay students, in aqueous medium it is neutral compound. It is not going to react very fast. Ether do not react with bases, cold dilute acids, reducing agents, oxidizing agents, and or you can say active metals like sodium. So students, ether do not react with bases, cold dilute acid, reducing agent, oxidizing agent, and active metals, because it is what? It is neutral compound. Okay students. However students, ether dissolve in cold concentrated sulfuric acid due to formation of oxonium salt. It is forming, students, ether is what? Having this property students, it is dissolved in cold concentrated sulfuric acid. How it is dissolving students? It is forming oxonium salt. Say for example students, I am taking mixed ether students. Oxygen is 2 valency, one valency by alkyl, other is by another alkyl that I am showing with R dash. Now what happens students when you add cold concentrated sulfuric acid? Oxygen, which is divalent students, because of sulfuric acid students, it is going to form the trivalent like this students. This both the valency by alkyl and another alkyl are R dash, and other will be the hydrogen of sulfuric acid. It is occupied by hydrogen. Because of this hydrogen, this oxygen will be positive charge, and this is the sulfate, per sulfate students, which is negative charge. So because of it is cation, this is what? Anion. So this way students, this is dissociated. So here students, when you add, this is ether students. How it is dissolved in ether students? This way it is dissolving in ether. Understanding? Very important students. Now students, this property distinguishes ether from other hydrocarbon. This is very important properties students. This way students, you can identify given compound is what? Ether. Second students, the reaction involving alkyl group of ether. Okay students, only the alkyl group will participate in the, that is called as reaction involving alkyl group of ether. Ether having 2 valency, both the valencies are occupied by alkyl group. Now only the alkyl group will participate in the bonding. That is why it is called a reaction involving alkyl group of ether. Now students, how it is involving students? So students, when the alkyl group of ether involve, it will form the peroxide. Alkyl group of ethers combines with atmospheric oxygen, and it is forming peroxide. Okay students, if you keep ether outside students, it will combine with the oxygen of the atmosphere, and it is forming the peroxide. Say for example students, here I am showing the oxygen, 2 valency students, other valency I am showing with, this is ethyl group students, and here also you have ethyl group. So this is diethyl ether students. Now what happens students when it will combine with the atmospheric oxygen that I am showing with O2? This is oxygen molecule students. Now here students, when it will expose to long time students, what happens students? This oxygen will form the bond here. Okay students. Now here the hydrogen, this hydrogen students, now combine, this will be as it is. Okay students, now one of the hydrogen will form the bond like this. So one hydrogen will come here students. Now one will be remain as it is, and this is methyl group. So this way students, it will form the peroxide. This is the peroxide of diethyl ether. So this is your diethyl ether. So this diethyl ether is converted into peroxide diethyl ether. So understanding students? So here only the alkyl group is involved students in the formation of peroxide. That is why here the reaction involving alkyl group of ether. Now all ether students which have been exposed to the atmosphere, it will contain peroxide. This is very undesirable reaction. Understanding students? So long exposure to ether, it will form peroxide ether. Now peroxides are hazardous because they decompose violently at high temperature students. So this is very important students. You have to avoid the oxygen, otherwise it will form the peroxides, and peroxides, all the peroxide after some time they will decompose, and it is very hazardous to the atmosphere. Third type of reaction of ether is reaction involving carbon and oxygen bond, where the carbon and oxygen bond will break students. That I am going to see here students. Now reaction involving carbon oxygen bond. the reaction with hot dilute sulfuric acid. Okay students, ether is having two valence, this is the oxygen. Now here the carbon of the alkyl, this bond will break. Okay students, so here students you have alkyl is containing carbon students, that you are knowing. Now students, the bond between carbon and oxygen will break. When it will break students, so when you add hot dilute sulfuric acid, so ethers when heated with dilute sulfuric acid undergoes hydrolysis and it will form alcohols or phenols. Okay students, so ether is converted into alcohols and phenol. So students, this way I am showing water molecule like this. When you are using hot dilute sulfuric acid, since it is dilute, so it will contain water. Okay students, so you can also show like this students, there is a formation of hydronium ion. Understanding students? So this is acidic in nature. What happens students? Here the bond will break. Okay students, now this alkyl will combines with hydroxyl of this water, and this alkoxide, there is alkoxide, it will combines with hydrogen. It is combining with hydrogen and you will find two molecules of alcohol. There is a formation of two molecules of alcohol like this. So this way students, you have got the alcohol molecules. This is called as hydrolysis reaction students. There is a breaking of hydrogen water molecules, that is why it is called as hydrolysis. Understanding students? So when the hydrolysis will take place students, when in presence of acid like dilute sulfuric acid. So students, this ether on hydrolysis, it will gives you alcohol. This is symmetrical ether. Here students, I have used symmetrical ether. Then there is an unsymmetrical ether like this students. Oxygen 2 valency, 1 valency by alkyl, other will be another alkyl. This is unsymmetrical. Combines with water molecules like this students. That hydronium ion you can show like this students, and just heat it in presence of dilute sulfuric acid. So what happens students, here also carbon and oxygen bond will break, and here the water hydrolysis will take place students. Now what happens students, here the alkoxide, one of the alkoxide now react with hydrogen of water molecules and it will form alkyl alcohol like this students. And other type of this alkyl R dash of this alkyl of ether now react with hydroxyl of water molecules and form R dash OH, that is another alcohol. So you are getting two different types of alcohol. Similarly, you can also use aromatic alcohol. Suppose you are aromatic ether. If you are using aromatic ether, this is aromatic ether students. Now react with water molecules. This water molecule, acidic water students, acidic water you are getting from dilute H2SO4. Now students, here what happens students, here the bond between carbon and oxygen, it will break. Now this is phenoxide. Now phenoxide of ether now react with hydrogen, this hydrogen, and it will form phenol. And this alkyl of ether now react with hydroxyl of water molecules and form ROH. So this way students, you have got phenol and alcohol, mixture of alcohol and phenol you have got. So this is the mixture of phenol and alcohol. So this is the students reaction we have seen. Action of acidic water on ether. A reaction of ether with phosphorus pentachloride. Ether react with phosphorus pentachloride to give alkyl chlorides. Okay students, so here students, I have taken mixed ether. This is mixed ether. When react with phosphorus pentachloride PCl5 and just heat it, you will find there is breaking of carbon oxygen bond here students. Now what happens students, this will combines with one of the chlorine of phosphorus pentachloride and form RCl. And what happens students, here that this bond is also break and it will form another alkyl halide, that is R-Cl. So you are getting mixture of alkyl halide, and this oxygen now combines with phosphorus trichloride, that is it will gives you POCl3. Okay students, so this type of mixture of alkyl halide you are getting. Now reaction with hot and cold hydrogen halide. We are going to react ether with hot and cold hydrogen halide. In hydrogen halide, hydrogen iodide is more reactive as compared to hydrogen bromide, as compared to hydrogen chloride. Okay students, so reactivity is go on decreasing from iodine to chlorine in hydrogen halide students. So hydrogen iodide is more reactive as compared to hydrogen bromide, as compared to hydrogen chloride. Here students, hot and cold word is very important students. Here in general I am writing students, suppose you have symmetrical ether ROR. Okay students, and another you have unsymmetrical ether, that is RR dash. Now students, we are going to add hydrogen halide. Now students, in cold state students, when you add hydrogen halide in cold state students, you will find a mixture. Here also there is a breaking of carbon and oxygen bond like this students, and here also the bond will break and it will form. Now this react with halide of this hydrogen halide and it will form RX. Now this alkoxide now react with hydrogen and it will form alcohol. So there is formation of alcohol as well as alkyl halide in cold state. What happens students when you add in hot conditions students? In hot state students, here also students I am taking only the simple ether. All are simple ether. So students, here the simple ether, when oxygen alkyl group is attached, same alkyl group is attached to oxygen, we call it simple ether. Now students, when it will react with in hot conditions students, so what happens students? There is a elimination of water molecules. Okay students, for water molecules students, if you want to remove water molecules, if you heat anything, it will eliminate water molecules. So here 2 molecule of hydrogen halide is required students. Okay students, so this oxygen now combines with 2 hydrogen atom and it will form water molecules. Plus students, here you are getting 2 alkyl and 2 halide, so it will form 2 molecules of alkyl halide. Okay students, so you are getting 2 molecules of alkyl halide and water. So simple ether react with 2 molecules. So yeah, so in cold state and hot state, in hot state students there is no formation of alcohol, only the in cold state students you will find alcohol if you are using simple ether. In second students, now oxygen is there students. Now here students I am using mixed ether R dash. Here is also you have mixed ether R dash. So this is the mixed ether students. Now what happens students? Action of hydrogen halide. Here students, action of hydrogen halide. Now in cold state students, how it will combine, and in hot state. Okay students, so if you have mixed ether students, how it is combining with hydrogen halide. So students, what happens students? Lower, this is the lower one, lower alkyl, this is what? Higher alkyl, this is higher and this is what? Lower. So lower alkyl of ether combines with halogen. In cold state it will combines with halogen. Lower one combines with halogen and it will form RX. Okay students, and higher alkane students, that is alkoxide, this will combines with hydrogen of halide and it will form R-OH. So this is lower will always form alkyl halide and higher will form alcohol. So it is always forming the alcohol. Understanding students? Same way students, when in hot state students, what happened when you are using hot state? There is a elimination of water molecules students. For that students, there is a elimination of water molecules. So this oxygen will go with these 2 hydrogen atom and form water molecules. And what happens students? You are getting 2 mixed type of alkyl halide, RX and R-X. Okay students, so you are getting mixed alkyl halide. So this is very important students. So this way it will react and it will forming the mixed alkyl halide. Now students, when you have example students, ether is students, here the methyl group, and if you have tert-butyl group C, and this is attached to 3-methyl group, so this is tert-butyl, and this is what? Methyl. Action of HI, hydrogen iodide. So what happens students? See this will break students. Here breakage will take place from here and it will form CH3 thrice combines with iodine. There is a formation of tert-butyl. This is tert-butyl, and there is a formation of methanol OH. So here this methoxide react with hydrogen of hydrogen iodide and it will form methanol. Action of HI on anisole. This is the aromatic ether students, anisole, that we are going to show like this. This is the aromatic oxygen is having 2 valency, 1 valency is by methyl group, other by phenyl group. So this is the anisole students. Now action of HI on this anisole students. So here students, the bond will break like this. In anisole students, if you are taking aromatic ether, so bond between carbon and oxygen will break from here and it will form phenol. Okay students, this phenoxide react with hydrogen of the iodide and it will form the phenol. Okay students, and this methyl react with iodine of HI and it will form methyl iodide. Electrophilic substitution in aromatic ether. So here students, in aromatic ether students, that is mostly we are taking here, we are going to take anisole. Okay students, now alkoxy group in aromatic ether is a ring activating, is called as what? Ring activating at ortho and para diaping group towards electrophilic aromatic substitution. So here the alkoxy group is very important students, because of that ring will activate at ortho and para position. Benzene is there students, benzene, it is less reactive as compared to anisole because of this methoxy. So here students, this will be more reactive at ortho and para position, otherwise it is what? Less reactive. Because of this methoxy group students, that is also called alkoxy group, aromatic, this is benzene here students, the electrophilic substitution will take place at ortho position. These two are ortho position and this is what? Para position. This is the carbon which are present, they are called as ortho carbon, and here it is what? Para. So first we students, here that is halogenation reaction we are going to see. Here students, anisole undergoes bromination with bromine in acetic acid even in absence of ferric bromide catalyst. So halogenation will take place here students. In halogenation, when halogen is going to be attached to the anisole, we call as halogenation. Now here in halogenation we are going to see bromination. So this is your anisole, oxygen 2 valency students, 1 valency by methyl, other by phenyl. So this is very important students. Anisole aromatic ether I have taken. This anisole when react with bromine in presence of acetic acid students. So a bromine will whether it will go to the ortho position or it will go to the para position. Here bromine is attached to the anisole, that is why it is called as bromination. Okay students, here you will find this will be at 90% and here you will find it is what? 10% yield. So 90% yield will be para bromo anisole. This yield will be 90% and you are getting ortho bromo anisole 10%. This is called as bromination students. So here again students, electrophilic substitution is taking place at ortho and para position. The Friedel reaction. For that students, we have taken anisole. Anisole react with alkyl halide or you can say acyl chloride in presence of anhydrous aluminum trichloride, that will be act as a Lewis acid as a catalyst. There is a, that is if it is alkyl halide where the alkyl is going to be attached, we call as alkylation. If acyl group is attached to the anisole, we call as acylation. So students, here these two words is very important, alkyl and acyl. Alkylation of anisole is called as alkylation of anisole. Here if it acyl is group is attached, we call as acylation of anisole. Okay students, first students we will see alkylation, where the alkyl is going to be attached to the anisole, we call as alkylation. So now here students, you have oxygen is 2 valency students, 1 valency by phenyl, other valency by methyl. So this is anisole students. Now when react with, we are taking alkyl halide instead of alkyl halide. I am taking very simple example, that is methyl chloride in presence of anhydrous aluminum trichloride students, which will be act as a catalyst. Methyl is attached to the para position, methylation will be at para position. So students, it is called as, this whole we call as toluene. Since methoxy group is attached, we call as 4-methoxy. You have to start the counting from here students. At 4th position you will find methoxy group, so 4-methoxy toluene, it is called as 4-methoxy toluene. Here students, methyl is attached to the 2nd position students. This is toluene, and when you start counting, number will be like this students. At 2nd position you will find methoxy group, this is nothing but 2-methoxy, and you have toluene. When benzene will come along with methyl group, we will call as toluene, it is called as toluene. So this is both are toluene and this is methoxy position. So this way students, this is called as alkylation. This whole reaction we call as what? Alkyl is added to the anisole, so it is also called as alkylation. Now students, since this reaction was described by Friedel, so it is also called as Friedel alkylation. Acylation, we are going to see the Friedel acylation of anisole. So this is your anisole students, oxygen having 2 valency, 1 valency by methyl, other by phenyl. So this is your anisole students. Now this anisole now react with acetyl chloride. Here this chlorine will negative, carbon will be positive. Now what happens students, in presence of anhydrous aluminum trichloride students, anhydrous. Now what happens students, there will be 2 position of carbon will be active, whether it is ortho or para. Okay students, now you are getting 2 types of product. Now this there is a elimination of two HCl molecules. Now here acetyl, this acetyl, out of this acetyl group is going to be substituted at, if it is substituted at para position, COCH3, we called as 4-methoxy acetophenol. This is whole molecule is acetophenol. At position number 3 you will find methoxy group is there, so this is called as 4-methoxy acetophenol. Since it is acetophenol students, same way here students, carbon combines with oxygen. Now this is the COCH3 students. Now we start counting. Since it is a acetophenol, both are what? Acetophenol. Phenol. This is ketone students. This is the both the one valency by alkyl, other by this, so we call as acetophenol. So students, because at second position you have methoxy group, so it is called as 2-methoxy acetophenol, and 4-methoxy acetophenol will form. Now here students, since it is para position, so it will be major product, and since it is at ortho position, because of the hindrance students, it will form minor product. There will be minor yield you are getting in 2-methoxy acetophenol, and you will find major product at 4-methoxy acetophenol. Now students, we are going to see nitration. Anisole reacts with the concentrated nitric acid in presence of concentrated sulfuric acid. Okay students, the mixture of nitric acid and sulfuric acid we call as nitrating mixture. Now which gives you ortho nitroanisole and para nitroanisole. Now this anisole react with nitrating mixture, that is mixture of HNO3 and mixture of H2SO4, which will gives you NO2. Now what happens is this nitrating mixture on nitration anisole, it will gives you mixture, two mixture product students. So first draw the structure of anisole like this. Now what happens students, if a nitrogen group is attached to para position, NO2, if it is attached to ortho position, so you are getting mixture of these two products. The name will be, this is your anisole students, so you have to start the numbering from this side. At position number 4 nitrogen group is there, so we call as 4-nitroanisole. At second position students, you have nitro group, we call as 2-nitroanisole. Okay students, so this will be the major product students, will be minor product. Okay students, so 2-nitroanisole will be the minor and 4-nitroanisole will be the major product. Why it is major students? Because this NO2 group is very far away from methoxy group, so you will get major product and it will be what? Minor product. Uses of alcohols, phenols and ether. So students, alcohol is very important students, compound students. So here students, very simple alcohol, that is methyl alcohol. Methyl alcohol is used as a solvent for paints and varnishes. If you want to dissolve paints and varnishes, methyl alcohol is used as a solvent. Now students, ethyl alcohol containing 2 carbon students, used as freezer agent in automobile, radiator. It is also used as a solvent. Understanding students? It is also used as anti-freezer agent in automobile and radiator. Uses of ether. Ether students, when diethyl ether is very important. Ether students, used as a solvent for Grignard reagent. In Grignard reagent students, diethyl ether is, every time we are using students, all the reaction is carried out under diethyl ether. So diethyl ether is used as a solvent in Grignard reagent. If you want to dissolve in fats and waxes and oil extra. Okay, so here we are using as a solvent students. If you want to dissolve fats, waxes and oil students, diethyl ether is very important. Now earlier students, this diethyl ether was used as a general anesthetic in surgical operation. So it is also used as an anesthetic agent during surgery students. In operation, it is given to the patient. Uses of phenol students. Phenol students, you are knowing phenol is used as a preparation of phenol formaldehyde resin. Resins are used students to prepare bakelite. If you want to prepare bakelite, which is heat resistance rubber students, which is made up of phenol formaldehyde resin. So phenol formaldehyde resin is made up of phenol. Here phenol is very important. Phenols are also used as an antiseptic. It is act as an antiseptic in common product like, it is also used in common product like air freshener. If you want to prepare students, in that also phenols are present. Deodorant, mouthwash, calamine lotion, floor cleaners, here the phenols are present. So these are the very important uses we have seen students, very important for the examination point of view. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.